Have you ever seen something that just defies logic? Something that glides over land and sea with equal grace, looking like it's floating on an invisible cloud? Well, that's a hovercraft for you. I've always been fascinated by these machines because they operate on a principle that's both brilliantly simple and, honestly, incredibly cool. They don't roll on wheels, and they don't slice through the water with a hull like a boat. Instead, they ride on a cushion of air, a pocket of pressure that lifts the entire vehicle just enough to break free from the grasp of the ground. It's a beautiful piece of engineering that solves a fundamental problem: friction. The first time you see a hovercraft in action, it's a bit of a mind-bender. It can transition from a sandy beach right into the choppy waves of the ocean, and then maybe onto a muddy swamp without even pausing. Let's talk about the arch nemesis of all things that move: friction. Friction is that invisible force that grabs onto your car's tires, that drags on a boat's hull, and that makes it hard to push a heavy box across the floor. The hovercraft, however, has a much more elegant solution. It cheats. The core principle behind a hovercraft is the creation of an air cushion. By forcing a large volume of air underneath its body and trapping it there, the hovercraft lifts itself completely off the surface. Think of it like an air hockey table. But instead of the puck floating on the table's air jets, the entire table is floating over the ground. It's all about separating the vehicle from the surface, creating a near-frictionless layer for it to glide upon. Imagine trying to slide a heavy book across a carpet. Now imagine you could somehow blow a constant stream of air under the book, lifting it just a millimeter. Suddenly, you could push that same book across the carpet with just a tiny nudge. This is where two key components come into play: the lift fan and the skirt. First, let's talk about the lift fan. This is a powerful downward-facing fan, often located near the front or center of the hovercraft. Its one and only job is to suck in a huge amount of air from above and force it down into the space beneath the craft's hull. This fan is the heart of the lift system, constantly pumping air to create and maintain the pressure needed to float. This is where the skirt comes in. The skirt is that flexible, rubbery-looking curtain that hangs around the edge of the hovercraft. It's one of the most brilliant parts of the design. This flexible skirt acts as a container, trapping the air from the lift fan and allowing the pressure to build up underneath. The real genius of the skirt is its flexibility. If the hovercraft encounters a rock, a log, or a wave, the skirt simply bends around it, maintaining the air seal as much as possible. This allows the craft to maintain its air cushion even when traveling over uneven surfaces. Once the hovercraft is up on its air cushion, it really needs a way to move forward, backward, and turn. And that's where the propulsion system comes in. The most common method you'll see is one or more large propellers mounted on the back of the craft, sort of like what you'd find on an airplane. By spinning really fast, they grab massive amounts of air and thrust it backward. Thanks to Newton's third law, for every action, there is an equal and opposite reaction. Pushing all that air backward creates a forward force that propels the hovercraft. Another method of propulsion is using air jets. Think of it like letting go of an untied balloon and watching it zip around the room. The air rushing out in one direction pushes the balloon in the opposite direction. A hovercraft typically has at least two engines, or one engine with a complex transmission system. One engine is dedicated to running the lift fan to keep the craft floating. The other engine is dedicated to the propulsion fans to make it go. So, you're floating on air and you've got a massive fan pushing you forward. How in the world do you steer? Steering a hovercraft is a unique skill, often described as being more like flying a helicopter or piloting a boat in a strong current than driving a car. The primary method of steering involves redirecting the thrust from the propulsion system. Behind the big propellers at the back, you'll find a set of large vertical rudders. They sit directly in the powerful blast of air coming from the propellers. On more advanced hovercrafts, pilots have a few more tricks up their sleeves. Some designs have side thrusters or puff ports, which are small vents on the sides of the hull that can release jets of air from the main lift system. Steering on water adds another layer of complexity. A strong crosswind can push the craft sideways, and the pilot has to constantly correct for it, a process known as crabbing. Piloting a hovercraft isn't just about pointing it where you want to go, it's about anticipating how the air, wind, and water will influence your every move. While they might seem like something out of a science fiction movie, hovercrafts are serious workhorses in a wide variety of real-world applications. One of their most important roles is in search and rescue operations. A hovercraft can glide seamlessly over all of it. The military was one of the earliest adopters of hovercraft technology. Large military hovercraft like the U.S. Navy's Landing Craft Air Cushion, LCAC, can carry tanks, heavy equipment, and dozens of troops directly from ships offshore, over the surf zone, and right onto a beach. Beyond rescue and military use, hovercrafts serve unique transportation needs. They can operate as ferries across frozen rivers in the winter and shallow rocky rivers in the summer, providing year-round transport where boats and cars would fail. Of course, there's also the recreational side. Smaller, personal-sized hovercrafts offer a totally unique driving experience, a thrilling mix of boating and flying just inches off the ground. From life-saving missions to high-speed racing, the hovercraft has carved out a niche for itself by doing what no other vehicle can, going just about anywhere. For all their amazing capabilities, hovercrafts are not without their challenges. One of the biggest and most constant issues is the skirt. As it glides over rocks, ice, debris, and abrasive sand, it's constantly subject to wear and tear. A small rip or a tear in the skirt can cause the air cushion to lose pressure. Another significant challenge is control, especially in rough conditions. Strong crosswinds can push the craft sideways, making it difficult to hold a straight line. Riding over large, choppy waves can be a bumpy and unsettling experience, as the craft heaves and sways with the water's surface. Then there's the noise. Let's be honest, hovercrafts are not subtle machines. Between the engine running the lift fan and the huge propulsion propellers spinning at the back, they can be incredibly loud. This can be a major issue for use in populated areas. Operating a hovercraft requires a unique set of skills that differs greatly from driving a car or a boat. The combination of skirt maintenance, tricky handling in rough weather, noise, and the need for specialized pilot training are all hurdles that have kept the hovercraft a specialized vehicle, rather than a common mode of transport for the masses.